The big goal of this section is to study what are the desirability of the allocations produced by the market from a point of view of equity or income distribution, and whether there is a role for government policy to improve such outcomes. Now, in order to study these questions, we need to build a simple model in which there is endogenous inequality that arises in an interesting way. And that is the first thing that we're going to do in this video. I want to start the description of the model by describing to you its basic structure. So as before, the model is going to have firms and consumers. Now, what is going to be different is that now there are going to be two markets and two goods. In particular, the consumers are going to sell labor to the firms, and in exchange, they are going to receive wages. And importantly, these wages are going to be their only source of income. The firms are then going to take this labor and are going to use it to produce good Q that they're going to sell to the consumers, just as before. And in exchange, the consumers are going to pay firms, and those payments are going to be the revenue of the firm. So the key difference is that now we need to look at a model with two markets, a market for good K and a labor market. But otherwise, as you will see in a second, things are pretty similar. Note that in this model, we're going to have to keep track of two prices, P, which is the price of good Q, just as before, W, which is the wage rate, or measured in dollars per unit of labor. And notice that L is the amount of labor sold, so we can put L there. Now let's begin to study the details of the model, first by looking at the consumer side of the economy. Before I do so, let me emphasize one thing, which is that the problems that we're going to study are actually quite complex, and the models can get very difficult. So to make things tractable, I'm going to develop an extremely simple version of the model with some strong assumptions. All of the results that I will create for you, I will derive for you, are going to be quite robust, and I will mention comments about that as we go along. But the model is going to be a very simple one, and the reason is mathematical tractability at this introductory level. Needless to say, more advanced courses in economics covers these kinds of questions in more generality. Okay, so let's look at the model of the consumer. The basic idea is that there are going to be C, consumers. This is the number of consumers. Every consumer has now exogenous wealth equal to 0. Because as mentioned in the previous part of the video, now wealth is going to be, or income is going to be endogenous. Okay? Now, the key thing is that they're going to have a utility function. This is the utility of I defined over three things. Q, the amount that they consume of Q. L, the number of hours that they work, and the amount of M that they consume. So let me emphasize that this is number of hours worked, or units of labor provided. If you want to use another scale, it's not that important what exactly units we use. We're going to assume that this is equal to Q, this linear on Q, minus L squared over 2 theta I. Theta is a parameter that depends on the individual plus M. Okay, and let's think about this parameter theta for a second. If you notice, this is a utility function increasing Q and M, but decreases in L. There is what is called disutility of labor. So we can think of 1 over theta I, which is going to be a positive number, as a measure of I's disutility of labor. Another way of thinking about it is as a cost of effort. And notice one thing, as theta I increases, so if we plot theta I, here is low disutility of labor, and here is very high disutility of labor. In other words, people with higher theta I have lower disutility of labor. Now, what is the maximization problem that a consumer like this needs to solve? What is consumer problem? It has to maximize, importantly now over two decisions, how much Q to buy and how much L to buy, greater or equal than 0 of Q minus L squared to theta, plus, notice there is no exogenous wealth, but this consumer gets labor income LW, and then it has to pay PQ to buy the good. Now, how do we solve this problem? Now we're going to maximize over two dimensions, but things are going to be very similar to before. All you have to do is, when you do the maximization problem, is when you're maximizing over Q, treat L as a constant, and when you're maximizing over L, treat Q as a constant. So let's look at the solution. First, let's look at the conditions for Q. The marginal benefit of Q is equal to 1. The marginal cost is equal to P. And that implies, it's very easy to see, that the demand for any consumer at price P is going to be equal to 0 if P is greater than 1, anything if P is equal to 1, because then this doesn't affect the utility, so he's willing to buy anything, or infinity if P is less than 1. Okay? If you're curious what that demand function like that looks like, I'm going to plot it here for you. It basically is 0 up to 1, and then it's just like this. We've seen this type of demand functions before. Now, notice that when we are horizontally, this is also the shape of the demand for the market at P, for good Q. Now let's look at good L. The marginal benefit of supplying labor is going to be W, and the marginal cost is going to be equal to L divided by theta. Since the marginal cost at 0 is 0, and the marginal benefit is greater than 0, we're going to get an integral solution, and in which these two things are equal. Doing the algebra implies that the labor supply of any person I at a wage W is equal to theta W. And adding horizontally, this is going to imply also that the labor supply of the market at wage W is equal to W times the sum over I, sorry, there should be an I there, theta I, and this is equal to W C theta bar, which I'm going to highlight here, that this is the mean or average theta. Let's check the intuition of these equations to make sure that they make sense. First, the marginal utility of consuming Q is linear, the marginal cost is linear, therefore there is going to be a precise solution. The consumer is going to have a strict preference for what level of Q it consumes only when P is different than 1. And that's why we get this, kind of this continuous shape. Now, the other thing to emphasize that is more interesting is that labor supply is theta I W. In other words, individuals who have a higher coefficient of theta I have less disutility of labor, end up supplying more hours, and notice that their income, that we're going to denote by I, this is income of I, is going to increase linearly with the square of the wage. Because why we say theta I W squared? Because it's the number of hours supplied times the wage per hour, which is W, gives you this. Now let's look at the firms at the other side of the market. We're going to assume that there are F firms and that they are identical, and all of them have a production function in which F of L is equal to gamma L. In other words, and where gamma is a positive constant, every unit of labor gets transformed into gamma L units of Q. Okay. Now, what is the maximization problem for a typical firm? Is maximize over L greater or equal than 0, P gamma L. Notice that gamma L is the output as a function of the level of input that it uses, so this is revenue, minus WL, and these are costs. The firms are competitive, they take the wages as given. What is the solution of this problem? Well, notice that the marginal benefit of L is P gamma, and the marginal cost is W. So this implies that the labor demand by firm J, any typical firm, is going to depend on both the wage and the price, and it's going to take the following shape. 0 if the wage exceeds P times gamma. Anything if the wage equals P times gamma, and infinity if the wage is less than P times gamma. Let's see why that is the case intuitively. The cost of 1 unit of labor is W. The revenue is P gamma. So there's basically linearity in both cost and revenue, which means that the firm is going to be infinity, because if the wage is less than P gamma, because if it makes a profit in the first unit, it makes a profit in every unit, and it can make infinite profits. The opposite is true when W is greater than P gamma, and when W is exactly equal to P gamma, it's indifferent and it doesn't care what it produces. If we add horizontally the labor demand for the market, we get that it's the same thing, for the same reasons we saw before. Now, what is the supply of a typical firm J? Well, it's just going to be lambda times the labor that it buys by the nature of the production function. Now let's add both things together to compute the competitive market equilibrium of the market or the economies. We need to extend the definition of competitive market equilibrium, given that there are two markets, and in this case it's going to be a P star, a wage star, and an allocation star. And by the way, the allocation is to describe what the people get in Q, L, and M goods, such that, not surprisingly, first, consumers optimize over QL given P star and W star. Second, firms optimize over QL given P star and W star. And third, there is market clearing in both markets. Now, let's see what this implies for prices and quantities. Let's see what we can derive. So I'm going to draw here the labor market, and I'm going to draw here the Q good market. And let's do things one at a time. So we know that the demand of the consumer looks like this. Okay, and it's here a price of 1. We also know that the demand of firms is there at a price of W equals P times gamma, and that the supply of labor is, as a function of the wage, is CW theta mean. Okay, now what do we know about the supply function of the firm? We know that it's also, I'm going to draw it in gray so it's clear, the supply function is also going to be something like this. If the price is very low, is very small, is like this, and then it becomes like this. Okay, we saw that before. Now this is the price of PW, this is as a function of P, as we just saw. And this is as a function of PW. Now here is the key to see how the equilibrium is. Now, for an equilibrium to exist, clearly these two curves need to cross. And there are only two options. Either they cross like this, and there is the quantity produced in equilibrium is 0, which means that the amount supplied in equilibrium has to be 0, which means that this cannot be an equilibrium since the labor supply at 0. The wage at 0 has to be 0, which means that the price has to be 0, which kind of doesn't hold altogether. So what you see is that in equilibrium, it has to be the case, and I'm going to erase this here to highlight it for you. It has to be the case that the supply also lies here on top of this, and that we have P star equals 1, W star equals gamma. Any quantity can be an equilibrium, and then that L star, which is going to be this, is given by C theta bar or theta mean gamma. That is the only set of prices that clears this market. Now, this may be counterintuitive at the first place. The key thing to notice, if you are missing the intuition in the first pass, is that there are only two possibilities for equilibrium, because there has to be equilibrium in the market Q, which is that this gray curve cuts like this, like above, in which case the quantity has to be 0, but that cannot be an equilibrium in this market given all of the other restrictions. So that means that this has to be like this, and if you check with these prices and quantities, this is an equilibrium. Now, if you think about it, this is very intuitive. The price in equilibrium of good Q is equal to its marginal benefit that it generates for the consumers equals 1, and the wage is the one that makes the firms indifferent about producing anything, because the profits are 0 at that marginal revenue and marginal cost, which has to be the case given that they have constant returns to scale production. Otherwise, an equilibrium would not exist. We have seen those things before. Now, if you're asking yourself, this example is really contrived, and I agree, it's a very special case that I have done for you, in order, as you will see, to be able to really derive a set of beautiful results over the next two videos. The key feature of this example, if this is bothering you, is that the equilibrium prices are pinned down and are going to be independent of any policy that we introduce, of any tax policy of the type that we're going to consider. If that was not the case, in more general models, we have to worry about what are called general equilibrium effects. General equilibrium effects, in which the taxes change some properties of the equilibrium, and that also needs to be taken into account, but it complicates the math. Now that we have characterized equilibrium, we can look at the level of inequality, either in terms of income, what is the income distribution that the model generates, or in terms of utility. Okay? And I'm going to remind you that we have found that in equilibrium, W star is equal to gamma. That's equilibrium wage. Okay? To simplify the notation below, I'm just going to call that, I'm going to take out the star, otherwise it's going to become a handful. Now, what is the income, as we saw before, of the individual in equilibrium? It's going to be equal to theta I times the wage, which is substituting theta I gamma squared. Now, a good measure of inequality is something like the variance. So what we get is that the variance in income, which remember is a measure of inequality, and it's a measure of inequality, just to remind you of the intuition for the variance if you haven't used it in a while, because it measures how it's spread out around the mean income is the distribution of income, is going to be equal to gamma to the fourth times the variance of the theta I. So this is a nice formula because it's telling us intuitively that the variance of income can be traced back to two parameters, this productivity of labor and the variance in the underlying kind of utility for effort. Remember, 1 over theta was the utility, so theta can be think of some sort of utility for employing effort. So the more variance there is in this fundamental or deep parameter of the model, and the higher the marginal product of labor, the higher the inequality. Now we can also think of this in terms of utility, and remember that we can write the utility of I in equilibrium as a minus L squared, the labor that they supply, divided by 2 theta, plus LW. We also have plus Q minus PQ, but this is equal to 0 because P is equal to 1. So we can ignore that. And now if we substitute the equilibrium values, this is giving us that this is equal to minus theta I W square, both of them, divided by 2 theta I plus theta I W square, which is just equal to theta I W square divided by 2. And again, if you want to think of a measure of inequality in the utilities, what we get is the variance of the UIs is going to be equal to W4, W to the 4, but again, W is just gamma, so it's gamma to the 4th divided by 4 times the variance of the theta I. Okay? This is a measure of inequality in income. Let me put it here. In income, inequality in utility. Notice that the formulas are very simple, not surprising, given that both income and utility in this simple model are linear in theta I, okay? And very closely resemble each other, since this is gamma squared. So just to recap, what have we done so far? We have built a slightly more complicated model of the economy, in which there are two markets, a market for labor and a market for the quantity for this good Q, in which income of the people are endogenous, and it can be traced back to these fundamental parameters, which has to do with what is the marginal product of labor and what is the disutility of labor that people have that affects how much labor they're willing to provide. And what we find is what is shown in this slide, that in equilibrium, the inequality, either in terms of utility or in terms of income, can be traced back to both, or increases in both, the marginal product of labor and the underlying variance in this disutility of labor parameter. The more unequal people are with respect to that disutility, the higher its variance, the more inequality in income and in utility that we will see.